Hello everyone and welcome to today's webinar. My name is Robert Salka and I'm part of the technical team of the London office of Midas IT. In today's session we will go through what improvements have been added to Civil 2017, namely with the release of the 2.1 version. Now these are the enhancements that have been added to Midas Civil. The ones that concern analysis and design are, a lot of them are for the Canadian standard, for the steel composite girder design, the pre-stressed concrete composite girder design, and some load combinations as per the Canadian standard. And then some steel composite girder design for improvements for the Indian code. And the ones that will be covering today are those for the moving load optimization as per the BS and Eurocode. And then some improvements to the pre-stressed composite girder design to Eurocode, some improvements to the moving load as per the British standards. And then for pre and post processing we have added a report function for the rail track analysis wizard. And also the automatic generation of strands for the pre-stressed composite bridge wizard. Now let's go straight into the improvements. One of the major improvements with this release is the changes made to the moving load analysis. What is changed now is that we have added the so-called moving load optimization. What this does is basically it allows us to define the carriageway by using only one lane definition. In the past, when we wanted to define the notional lanes, we needed to define each one of them independently. But now with this function, we can just define the carriageway directly and alongside that the remaining area, and then the optimization for the lanes is done both, for the vehicles is done both longitudinally and transversely within the lanes, but also the lanes themselves are switched automatically transversely along the bridge, and this saves a lot of time when it comes to the definition of the lanes. This is now available for AASHTO, British standards, Eurocode and the Russian code, and in the next release it will be available for other codes as well. Now as you can see in the screenshots here, now when we define traffic lanes and traffic line lanes and traffic surface lanes, we have another option called moving load optimization. This opens for us a definition window like this, in which we have to define the optimization lane width, which is basically the width of the carriageway minus the remaining area. And then the lane width, this is the width of the notional lane. Analysis lane offset, this is the transverse distance or the increment between the vehicle center lines. The wheel spacing, just as before, the wheel spacing of the vehicles. And the margin, this is basically the distance between the wheel of the vehicle and the boundary of the carriageway. And also an eccentricity, this is just as the classic way of defining lanes, the eccentricity between the center line of the lane, which this time is the carriageway, and the reference line. All the rest of the definitions are exactly the same as before. Now another addition now is in the way we define the moving load cases. Now we have this option here called moving load optimization. When we tick this on, we have an option where we can choose now the optimization lane. Also we have an option for defining the minimum distance between vehicles when it does the transverse optimization, and also the number of loaded lanes, and we can also define the footway and the remaining area. Now this is a visual explanation of what I've just explained. So we have the width of the carriageway over here, then the lane width, the wheel spacing, the margin, so the distance between the wheel and the boundary of the carriageway, and also the minimum distance between the vehicles defined here. and then the optimization is done for the lane considering our definitions. The lanes are basically generated using this these steps over here. The first step is finding the center line of the carriageway. This is where the first center line of the vehicle will be generated, and then considering the analysis lane offset distance, the second center line will be generated, one to the right and one to the left, and then so on and so forth. The rest of the positions of the center lines of the vehicles will be generated up to the end of the carriageway. Now, this is an example of the improvement that this way of defining the lanes can bring. For example, this is an old way of defining lanes. As you know, now we are restricted to specific positions for the notional lanes, whereas on the right hand side we have the moving load optimization. This is when we look from the front of the bridge, so basically from this view, this is what we see. We can see this is the element of interest for us. We can see now that because we are bound here to this position of the lane, we cannot go with the vehicle over. But with the moving load optimization, this is automatically done, and you can see now that the maximum effect in this example, the bending moment, the maximum effect is increased compared to the old way of defining the lanes. Now, in the model, this looks something like this. We have the classic way of defining lanes, as I have here for the remaining area, but we also have the moving load optimization lane. You can see all the items that I've mentioned in the presentation. So when we want to define a lane, now you can see that we have two options now, and also the change in the moving load case definition. We have the classic way of defining moving load cases, or using the moving load optimization. And now when we check results, it is exactly the same as before, only this time the optimization is done. It is just much faster for us to define the lanes, and the optimization is done in a better manner. And we can check the results just as before. Now, the second major improvement that comes with this new release is to do with the pre-stressed composite girder design. Namely, the major improvement is that until now, the beta factor, when we considered shear at the interface between concrete cast at different times, was considered as 1, a conservative value. But now we also have the option of having the exact calculation as per 6.2.5 of Eurocode 2, and you can see here the clause. Now, in order to have this exact calculation, when we define the parameters for the PSC design, we can now choose how we want to have beta calculated, if we want to have the value of 1 or exact calculation. And now let me show you this in a model. You can see now I'm in PSC design, and we now have this option here. And now when we generate the design report, if we scroll down to the check for interface shear, we can see here now that the beta factor is calculated as a ratio of the longitudinal force for the girder and for the slab. Other improvements to the PSC design are the fact that now we have a detailed calculation for the stress limit checks. So now at the bottom of at the end of the report, we can now check the stress limits for the tendons and the concrete. I mean, these were done before as well, but now we can see the actual calculation. And another addition is the check as per clause 7.3.2 of Eurocode 2 part 1, namely the check for whether minimum reinforcement is required or not. And again, we can see this in the report with the clause and all the items for the check. Another improvement that comes with 2017 V2.1 is that the fact that now when we run a moving load analysis as per the British standards, we can now choose to have the vehicles travel in forward, backwards, or both directions. In the past, we didn't have this option, and when we had bridges that were asymmetrical, this might become a problem. And another addition is, in the past, the SV train wasn't applied alone on the structure, but now in the new version, SV train can be applied alongside HA vehicles, and the SV train is applied only on one lane. Now I have here a model for the, you can see I'm using the VS Code, and now in the lane definition we can choose to run the model forwards, backwards, or in both directions. And I have here a moving load case with an SV train, and if we check the tracer, now we can see the SV train applied only on one lane. The next improvement that comes with Civil 2017 V2.1 is the option of automatically generating a report for the rail track analysis wizard. As you know, the rail track analysis wizard generates the structure for us, a bridge for us with the rails and information about the bed used for the rails, and it is used to basically simulate a rail structure interaction. Now with this addition, we can automatically generate a report with all the graphs and the checks as per UIC 774-3, and we can see checks for the rail axial stress with temperature, variation in the deck, and displacements at the ends of the spans, and rotations at the end. Also, another important other checks include, as I said, a relative displacement between the deck and the rail, displacement axial stress in the rail due to traction and braking or due to vertical loads. An important mention is that for the moment this report is only available for the simplified analysis. So I have here a model. Here we have the rail wizard, and as I mentioned, this works only with the simplified separate analysis. So we can choose all of these, and the report can be generated for these. Now the function for the report is here, and we can select, if we go to a folder where the wizard has generated all these models for the relative displacement, rotation, expansion, joints, checks, and we can, the report will be generated for all of these. Afterwards, we can also check, we can also assign some checking criteria, such as compressive stress, allowable compressive strength, stress or tensile stress in the rail, or a horizontal displacement, or displacement between the top of the deck and embankment, or between the bottom of two consecutive deck ends. And when we click OK, the software automatically compiles all the results from these models, and it will generate a report. And the report looks like this. So we have, firstly, we have a summary sheet where we have all the graphs. So, for example, rail axial stress due to temperature variation at the deck for track 1 and track 2, track 1 and track 2, rail 1 and rail 2, sorry. And then stress in the rail due to braking and traction, stress in the rail due to vertical bending, and here we have the maximum values as well. So the maximum compressive and maximum tensile values, and also the checks. Rail now combined stress verification, so stress due to temperature, braking, traction, and vertical effect, and the check. Also horizontal displacement in the deck due to braking and traction, relative horizontal deformation between rail and deck due to braking and traction again, and for the second rail, and deck end rotations caused by vertical loads, and also deck end vertical displacement due to temperature plus braking and vertical loads. And after checking the summary sheets, we can also check each of these independently. We can see the maximum values for the stresses and also all of the values that were compiled to generate these graphs, and we can check this for each of them. So this report can save a lot of time when it comes to compiling the results for this type of analysis for a rail structure interaction. And now the last enhancement that I will be covering today is the one done for the pre-stressed composite bridge wizard. In the past we had to define each of these tendons independently, but now we can use, if you're familiar with the function tendon template, this is what it basically does. It loads this auto generation option in which the software automatically recognizes what type of section we have, and it automatically generates a tendon template for us, and then from there we can edit these. To show you on a model, we'll open a wizard here. For those of you that aren't familiar with the wizard, this is a tool which is very helpful when it comes to easily generating the geometries for bridges. With this wizard we can choose the dimensions of the bridge by simply defining the values here. We can define skews, offsets to our girders, what type of elements we want to use, if we want to analyze everything in frames or in a combination of plate elements and beam elements, if we want to include superstructure or not. Then information about the sections, section offsets, how we want to treat the diaphragm, if we girder information here, and if we have different girders for different spans, we can assign that as well. And then the improvement that has been added now, you can see here that I have a TY7 section and no tendons defined yet. If I choose auto generation, the software recognizes what type of section I have, and we click OK, and now we have the default tendon layout here, and we can go and delete the ones that we're not interested in. In the past, we needed to choose what type of tendon we have, choose a property, define number of tendons, transverse distance between them, and then offset along the vertical direction. But now this is automatically done by simply using auto generation. So if we use standard type sections, this saves a lot of time. Now this is all for this short webinar. I hope many of you will go and download the latest version and will be very much helped by the new enhancements. I should mention that if you go on our website now, you will see that there is actually a version 2.2 available, and that is basically just 2.1 but with a couple of bug fixes and improvements. So all of the improvement that you've seen today will be available there as well. Thank you for your attention, and good luck with your projects. Have a nice day. Bye bye.